Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about financial maths. Now the question that I've chosen to go through here is 2015 Paper 1 Question 6A Part 1. In this question we're told that Donagh is considering taking out a loan and he's offered two different repayment options. Bank A offers him a monthly interest rate of 0.35%. So my monthly interest rate is 0.35%. And I'm being asked to find the corresponding APR, or in other words, the corresponding yearly interest rate. If he earns 0.35% interest every year, what does that correspond, every month, what does that correspond to over the course of a year? In order to work this out, we need to use the formula from our log tables. F is equal to P times 1 plus I to the power of T, where P is equal to the present value, F is the future value, I is the interest rate, and T is the amount of periods, or in this case, the amount of months in a year. The first thing you should recognize is that if they usually give you the interest as a percentage, but we don't want the interest as a percentage. We want the interest as a decimal. So I need to get rid of this percentage. And to do that, I want to divide by 100. So the monthly interest that I'm going to use, I divide this by 100, it's 0.0035. So you'll notice that I'm calling this IM, that's the interest rate, the monthly interest rate. So it's just important we don't confuse the monthly interest rate I with the yearly interest rate I. So now my present value, you can actually just make up whatever figure you want here. Obviously the easiest figure to make up is 1, okay? Let's say Donagh's going to start the year with €1. If in theory I started the year with €1, let's say I start off with €1, okay? And then I'm just going to sub in my 1 plus I. So 1 plus my monthly interest rate in this case is 0.0035. So 1 plus I is 1.0035. And now I need to ask myself, how many times am I going to earn the monthly interest rate over the course of a year? Well, clearly there's 12 months in the year. So in this case, I'm going to earn the monthly interest rate 12 times in a year. So what I'm calculating here is, if I started the year with €1 and I earned a monthly interest rate of 0.0035, that means I'd earn the monthly interest rate 12 times. So if I plug this into my calculator, that's going to tell me what I would end the year with. If I earn the monthly interest rate 12 times and I started off with €1, that means I would end the year with €1.042818. So after I earned the monthly interest rate 12 times, my €1 has become this much. So this is the future value. And this is going to allow me to work out what the APR or the yearly interest rate is. In this context, now I want to introduce I, and I'm going to call it IY, which is the yearly interest rate. The 1.042818 represents the amount of interest we would earn in a year. So that's just the 0.042818 is the amount of interest I earned. The €1, I originally started off with €1, so I want to get rid of that. So I want you to think of 1.042818 as the €1 you started off with plus the interest that you've earned. So in other words, what we need to do is subtract 1 from both of these. So I can say that IY, or the yearly interest rate, is equal to 0.42818. It's equal to, 0.042818. So the yearly interest rate is that much. It's the amount of interest I've earned in a year. But they asked me to get this as a percentage. So I have to do the opposite of what I did here. This time, to convert this to a percentage, I need to multiply by 100, which means that the yearly interest rate, or the APR, is equal to 4.28%. So if I multiply this by 100, I get just 4.28, and it asked me to get it as a percentage, so my APR, or my yearly interest rate, is 4.28%. Okay, so in the second part of this question, we're told that Donagh borrows €80,000. The monthly interest rate is 0.35%, and that he's going to pay back the same amount every month for 10 years. So 12 by 10, that means he's going to make 120 repayments. And the interest we're going to use, we divide the percentage by 100, it's 0.0035. We're asked to find the value of each of these equal monthly repayments. Now I want you to be aware that there's two ways of doing this question. You can do this by using the sum of a finite geometric series, or you can use it by doing the amortization formula. Now I think it's quite likely in the leave insert that you won't be given a choice, so that they'll actually tell you which one to use, which means it's very important that you can do this by both methods. So I'm going to do this question by using the sum of a finite geometric series. And when you're finished watching the video, I want you to try and use it by just subbing into the amortization formula. So if you will, I'm doing kind of the trickier version of it, and then I want you to try the formula. So to come up with a geometric series for these repayments, we need to use the present value formula from our log tables. We use this formula if we're paying back a loan. So now we don't use this formula if we're saving money. If we're saving money, we use the formula for compound interest. But if we're paying back a loan, in order to come up with our geometric series, we're going to sub into this formula. So I'm told as well that the first installment goes in at the end of the first month. So my first future value, let's call the value of each repayment A. So the value of each repayment, we're going to call it A. Okay? So to come up with my first term, it's A, which is the future value. The reason A is the future value is because in a month, I'm going to pay €1. So I'm going to start paying back my loan in a month. So A is the future value. So in the future, I'm going to pay the bank this much money. So the present value is the future value divided by the interest rate to the power of t. My 1 plus I in this case is going to be 1.0035. And the first installment is going to go in a month. So that means it's all of this to the power of 1. It's going to be in 1 month, or one time period, because my interest rate is per month. So it's been 1 month since I made my first. It's going to be 1 month before I make my first installment. So my first term is just A over 1.0035. My second repayment is going to go in 2 months. So it's going to be A over 1.0035 squared. My third one is going to be A over 1.0035 to the power of 3, next one to the power of 4, to the power of 5, and so on. So I can just put ... because obviously I'm not going to write in 120 terms. The only other term I need to write in is the very last term. The very last one is going to be A over 1.0035. And if the first one is over 1 and the second one is over 2, clearly the 120th one is to the power of 120. So it's A over 1.0035 to the power of 120. Once I have my geometric series written out, it's going to be relatively straightforward now to get the sum of a geometric series. Remember, I know that when I add all of these together, they're going to pay back the loan. So when I add all of these together, they have to add up to 80,000. So my 120 repayments have to add up to 80,000. Now the formula for the sum of a geometric series is Sn is equal to A times 1 minus or to the power of n over 1 minus or. I know that Sn, the sum of all of the series, is 80,000. So straight away I already know what my Sn is. And I know that n, which is the number of terms, I know that n is 120. So in order to sub into this, all I need to do is work out what is my A and what is my or. So A is your first term in your geometric series. So clearly the first term in my geometric series is A over 1.0035. So capital A, remember capital A stands for the value of each repayment, whereas the small a in this case stands for the first term in my geometric series. So my small a is capital A over 1.0035. And or is the common ratio. To get the common ratio of a geometric series, it's any term divided by the previous term. So if I got the second term and divided it by the first term, that would just work out as 1 over 1.0035. So now I know all of my unknowns and I can just substrate into this formula. So instead of Sn, I can put in 80,000. I know the sum of the geometric series is 80,000. I know that A, which is my first term, is capital A over 1.0035. And in my bracket, I've got 1 minus or, which is 1.0035, to the power of n, which is 120. And that's all divided by 1 minus or. So that's 1 minus 1 over 1.0035. So to be honest, that's the financial maths bit of the question done. And now you'll notice that I got one equation and I've only got one unknown, my capital A, where capital A represents the value of each repayment. So for the rest of this, it's kind of just basically calculator work. Now it is quite tricky, so what I want you to do is pause the video and maybe try and work out your A, and you want to get it to the closest, to the nearest euro. And then what I'm going to do is I'm going to start again from the top and work it out. Okay, so again, I honestly find that this is the bit that students usually make mistakes on. It's the financial maths at the start. People are usually relatively good at coming up with their geometric series, but it's at this point where your calculator work can often cost you. Notice in some of these cases I'm going to 6 and 7 decimal places. For the financial maths, overkill is underrated. You need to go to as many decimals as possible. So I would go to as many decimals as my calculator would give me. I've seen questions where unless you go to at least 6 decimal places, you don't get the right answer. So make sure you're not just rounding to 2 decimal places or to 3 decimal places. Go for overkill in your financial maths. So I started off, this is where we left the last frame at, and I decided to multiply both sides by 1 minus 1 over 1.0035, which essentially just means it's the bottom of the right hand side multiplied by the left. So, and what I also did was I got this bracket on the top of my fraction, plugged it into my calculator, got 0.34247111. On the next line I've multiplied 80,000 by this bracket, I got 279.023418. On the next line what I'm doing is dividing both sides by 0.34247111 in order to isolate my A over 1.0035. So when I do that, I end up with A over 1.0035 is equal to 814.73566. Then multiply both sides by 1.0035 in order to isolate my A. So I get A on its own, and A is equal to 817.587. Now the question asked me to leave my answer to the nearest euro, which means my final answer is 818. So if Donut makes 120 repayments of 818 euro every month for 10 years, he'll pay back his 80 grand loan. Okay, so again, I hope this video made sense. Just one thing I want to stress there is that the template we use to solve part B here, we have to use a slightly different one when we're saving money. We have to use a different formula. We have to use our compound interest formula to come up with our geometric series, as opposed to using the present value formula. So we use the present value formula there because we were paying back a loan. So we use this formula usually if we're paying back a loan or if someone is paying us back a pension. So in this case, I just want you to be aware that make sure you don't confuse. For me, there's two different types of these questions. There's ones where you're saving money and there's ones where you're paying money back. Again, I hope the video made sense. If you have any questions, again, just ask me in class and I'll try and explain it differently.